Otherwise, we'll start recording.
Okay, we're good?
Yep, we're good.
Good?
Yeah, we're good.
Okay. All right, everybody, let's get started. I'm gonna introduce Dr. Hyunkyoung Yoon. I'm so happy to have Dr. Yoon today as a colloquium speaker, especially in person. She did her PhD at Arizona State University, and now she's teaching at ASU as well. And then today she's talking about the teachers' meeting, or how teachers' meetings are conveyed to their students, and a little bit about our research team, because she has a strong connection to UGA MESA Education, because she is working as a co-PI at COVID Pager project with Dr. Barley. So yeah. Dr. Moore. Yeah, with Dr. Moore. Right.
Thank you for having me today. Hello, everyone. I'm Hyunkyoung Yoon from Arizona State University. I actually come from South Korea, so I will show you the South Korean citizens interview today as well. So, like Mina said, I'm working with Dr. Miley and Dr. Moore and Heather, Mina, James, and Drew on COVID Pager grant. So nice to meet you, everyone. So today I will talk about this research, what Terry conveyed to her students. It came from my dissertation. So for this talk, I want you to be either Amy or Alex. So I'm gonna give you this name tag. So today, delete what you have in your brain. So you will be Amy or Alex, right? Does it work? So Mina will help me to give you this name tag. So I will ask you questions, Amy and Alex. So it's up to you. You can be Amy or Alex. It's up to you. This is
You want to go see it?
Yep. Thank you so much. That's why I do have two sides. Many people prefer Amy.
It's like so many people have
Cameron should be Alex. Actually, I work with 8 Korean teachers and 1 teacher in the United States. The reason is teachers in the United States didn't volunteer. Yeah, as you expected. So one United States teacher, her name is Terry. So this is what she said when I interviewed her after her lesson. So let's listen to what she said.
And I would not have any idea that she would get that. So we did not. No, not at all.
Can you believe it? So Terry said after watching her students' video clips, so I played her students' video clips so that she can see how her students understood. So after watching her students' video clip, she said she had no idea why her students didn't get it. So it's pretty normal, right? So when we teach mathematics or when we teach something, we found inconsistency between our intention and students' real understanding. So I thought about why, because the 9 teachers who I work with, they failed to convey what they intended. And I asked this question before their lesson to see their image of student thinking. So what do you think how your students might understand about the mathematical idea you will teach that is different than what you intend? Many teachers said they will get it because they will learn from me. So it seems they had no image of how students might understand their instruction actions before their lesson. So they just assumed they would get it. So this is my starting point of my research. I wanted to see the conveyed meaning from a teacher to her students. And at the same time, I wanted to see teachers' image of student thinking, how teachers' image of student thinking influence their meaning conveyed. So today's talk will be consist of 2 studies. The study 1 is about conveyance meaning from Terry to her students. Study 2 is about our COVID pager. The mathematical idea for the talk is going to be rate of change because Terry taught the definition of derivative. So it includes rate of change or slope idea, right? So I will show you an item from COVID pager research regarding rate of change in study 2. The study 1, the focus of the study 1 is going to be how teachers convey meanings to their students. And study 2, the study 1 came from Project Aspire, funded by NSF. I was on RA in this grant. And study 2 is about South Korean and United States citizens' mathematical understanding, how their mathematics supports them in interpreting COVID-19 quantitative data. So this study comes from COVID pager. We are working on this grant right now. Let's go to study 1 first. Here is a classroom. So this teacher has her own meaning in her head, right? And she's teaching rate of change idea, and she's using her own meaning when she teaches mathematics, right? That's what we are doing. And her student tries to understand what she said, and in doing so, his student constructs his own meaning from his head, right? It's gonna be his own meaning. So my main interest was what Terry conveyed to her students in this classroom after classroom observation. And I interviewed the teacher, and I interviewed her students as well to see the conveyed meaning from Terry to her students. So 2 things in my research question. Number 1, the meanings Terry conveyed to students. So what meanings students construct from Terry's lessons. I will talk about what I meant by the conveyed meaning from Terry to her students later in my theoretical perspective. And the second focus was related to what I told you at the beginning. The teacher's image of student thinking, I call this KPU, which is key pedagogical understanding. So I wanted to see Terry's development of KPU to see how Terry's image of student thinking influences her instructional actions. So there are 2 parts in my research question. MKT is pretty famous, right? The MKT people classified what a teacher knows in the practice of teaching. But they didn't define what they mean by knowledge. So they cannot connect what a teacher knows and what a teacher does in classroom and what their students actually understand. So I feel like there is the need to connect teachers' instructional actions with what their students actually learn from them. So my stance is consistent with what mathematical understanding allow a teacher to act in those ways spontaneously, or how might these understanding develop. So my research is pretty different from MKT research because I focused on the connection between teachers' meanings and their instruction actions and students' meanings from the teacher. 2 parts in my theoretical perspective. Number 1, conveyance of meaning. Number 2, KPU, key pedagogical understanding, which is about teachers' image of student thinking. There are 2 people, person A and person B. So let's suppose I'm the person A. So I'm talking about something because I want to convey something to you. And at the same time, I'm looking at your eyes, or because we do have a mask, so I cannot see your nose and mouth, but I can see your eyes. And I'm looking at your face and your reaction, your behavior to check how you might interpret me, right? That's what you're doing in your classroom. And this is what I'm doing. I'm looking at you to see how you might understand what I'm talking about, right? And you're person B, you are trying to understand what I'm saying, right? So this is your head. But the important thing is I'm constructing my model of your understanding by thinking about how I think you might interpret me. It's my understanding, it's my model, right? It's in my head. And at the same time, you are working on your understanding by thinking about what you would have meant if you were to say that, right? It's gonna be yours. So which means you are putting yourself in the place of me. It's yours. So if this is teacher-student situation, same thing. So this conveyance of meaning from a teacher to students can explain why teachers failed to convey what they intended. Because a student's understanding of what the teacher said comes from the student, not the teacher, right? And a student's understanding of teacher's action is not always the same as what the teacher meant. So our job is to make the gap between teacher's intention and student's understanding smaller and smaller, right? So conveyed meaning, I'm talking about something, I'm conveying something to you, but my meanings in my head do not fly to your head, right? So conveyed meaning doesn't mean transmission from a teacher to students. So any sense you made of my talk is going to be the meaning I conveyed, right? Same here. Any sense that a student made of what the teacher said is going to be the meaning the teacher conveyed. So this is what I mean by conveyed meaning from Terry to her students. So the conveyed meaning might or might not be the same as the teacher's meaning. So it can explain the inconsistency between teacher's intention and students' actual understanding. Is the speed pretty good, right? Pretty okay. Okay, I'm checking how you might interpret me to be a good teacher. The second part about my theoretical perspective is about KPU, which is teacher's image of student thinking. There are 6 phases. They're pretty rough to understand right now, but I'm gonna use images. This teacher, the first teacher, in his head, only mathematical ideas, right? So he thinks students are human beings. So they are like me, so they will get it, like blank slate. I will teach it, they will get it. Nothing to do with student thinking. Second teacher, can you see? His teacher started to think about student thinking, but all is the same, A prime. So this teacher is teaching mathematical idea in ways that is clear to her because she is projecting herself by default. So they will understand it because they are like me. So only just his teacher assumed student's meaning will match her own. The third teacher, can you see? The third teacher tried to think about different ways of thinking, different ways of understanding. So number 1 and 2, I'm gonna say the number 1 and 2 teachers, their model is gonna be a first order model of students. But number 3, it's the beginning of a second order model because kind of try to decenter. So for example, teacher 2 will think students said slope is delta y over delta x, so they knew the slope because they are like me. They said delta y over delta x, it means they knew the slope. The teacher 2, but teacher 3, some students might think slope as steepness, although they talked about delta y over delta x, so I'm gonna connect steepness to the changes. Can you see the difference between the 2 teachers? So I will use this KPU to analyze Terry's data today. Any other questions so far? Is it clear? No misunderstanding?
Between the first and the second. So the second teacher, the first teacher is not thinking about students at all. It's more like there's nothing there. I'm pouring in. Whereas the second one is they're just like me. So
Yes, yeah, projecting her own meaning. The methodology. I observed 15 consecutive lessons taught by Terry. Her lesson was about calculus ideas. And Terry, I asked Terry to pick 2 middle performers who paid attention to her lessons because it's going to be ideal situation. Students should pay attention to her lessons to understand Terry's lessons, right? So she picked Amy and Alex. So you will be Amy and Alex today, right? But I conducted pre and post lesson interview with Terry and the two students, but I conducted pre-lesson interview with Terry first because I wanted to see her lesson go before observing her lesson. The pre-lesson interview with Terry, pre-lesson interview with Amy and Alex, and 5-minute post-lesson interview with Terry. Just briefly, Terry talked about how it went. And post-lesson interview with Amy and Alex, and then post-lesson interview with Terry. So the reason I conducted post-lesson interview with Terry at the end, I wanted to play the student video clips to see how she felt after watching her student video clips. So can you imagine how Terry felt? Sometimes she cried because, and sometimes she was really extremely happy. Yeah. This is the process classroom observation. So I conducted post-lesson interview with Amy and Alex after every 3 lessons because like every lesson, it would be a lot because they were really busy. Yeah. So I had 5 post-lesson interview with Amy and Alex at the end. And same here, after lesson 3, I conducted post-lesson interview with Terry because I conducted post-lesson interview with Amy and Alex. Can you see the structure of my observation? Any other questions? No? Clear? Okay. So I compared Amy and Alex's pre-lesson interview and post-lesson interview to see the meanings Terry conveyed to Amy and Alex. And I looked at her interviews and her decisions towards this lesson after watching Amy and Alex video clip and what she actually did in the lesson to see her KPU phases. So this is how I analyzed my data. So lesson topic for first 7 lessons. Lesson 1, she introduced the definition of derivative. So you know that, right? The definition of derivative. It in itself includes the difference quotient, right? So I thought the definition of derivative is related to slope or rate of change meanings. And then she kept teaching the derivative concept by using some algebraic strategies or decreasing or increasing rate. This is the definition of derivative that she taught. Look at this difference quotient, right? So that's why I asked Amy and Alex and Terry about their meanings for slope or rate of change. So Terry said in post lesson 1 interview, her goal is for students to find a derivative. So she will teach some algebra with comparable functions like x squared or x cubed because she thought students were familiar with those functions. And you will be either Amy or Alex. So keep in mind, if you are Amy, your meaning for slope is going up and over. It's a up and over motion. It's pretty common, right? For your students and my students as well. So Amy, your meaning for slope is up and over a motion. Okay, Alex, his meaning for slope was something about changes, relationship between delta x or delta y and delta y. So if you are Alex, your meaning for slope will be relationship between delta x and delta y. Are we good? Okay, going to Terry's lesson 1, Amy and Alex, you will learn from Terry's lesson 1. So I will ask you what you learned. Okay, ready for the lesson? Okay.
The instantaneous rate of change is called f prime of x. And f prime of x has been designated. And I'm going to write the definition. So we're going to actually do this. We're going to do this with other 4 functions we might have in 12 for today. Okay. What I said yesterday was, what did H stand for? Change in. So what does it stand for here? Change in x. Okay. So this is going to be new for you. The algebra involved is going to be fairly challenging. Believe me, it is. I'm going to teach you how to do it. Okay. But this formula zero be h a problem? Why if I plugged in zero, would that be a problem? I can't have zero down here because I can't divide this. Okay? So I'm going to show you strategies. Okay, and that's what they are. They're algebraic strategies. We're going to start with a really, really easy function. Before I do that, just want to get across that this is the definition of a differential.
Okay, did you learn from Terry? Amy, it's your turn. So what did you learn, Amy? How many of Amy's do we have? Amy, any volunteer? Amy, what did you learn? Slope. So what does it mean, the definition of derivative from Terry's lesson? Open over. So, but what about the limit? But limit plus open over? Yeah. We will see a real Amy, how real Amy answered. So this is pre-lesson 2 interview after lesson 1. So this pre-lesson 2 interview will show you how Amy learned from Terry's lesson 1, right? So let's listen to what Amy said and see how you.
Yeah, like she told us to plug it in yesterday. I kind of forgot how to.
Okay.
Tomorrow night.
What does this mean?
Like, so you use your original function and then you like plug it into the new formula to kind of find like the limit of it. And then like once you factor it and then like take out the like certain elements of it.
Okay.
And then
What did you see? Procedure, only procedures, right? And she said it and original function as well, the new formula, right? So did you look at this, what she wrote? 1 over x plus 1 over x. So because of her meaning for slope, it's only about a motion up and over. So she didn't represent a change in the numerator, right? And Terry told us plugging it in yesterday. So what is it? Isn't it 1 over x? So, and then Amy said use the original function and plug it into the new formula. So I analyzed Amy's pre-lesson 2 interview. So this is 1 over x, it, and this is the new formula. She plugged it in. This is what Amy learned. Do you agree? So as you know, mathematics education, we don't have any correct answer. So welcome to your thought if you don't agree with me. So do you agree? Is it pretty plausible? So this is what Amy learned because of her meaning for slope. And to Amy, functions are formulas, right? Pretty good formula. And the definition of derivative is a new formula, which is awesome, right? Because it gave her a new inscription through the sequence of actions, right? Like procedures, all about procedures and formulas. Alex, it's your turn.
Can I
So,
ask a question?
Mhm.
Did Amy think about the difference quotient as related to her meaning for slope at all? Or is it just like a separate thing?
She said,
Was there a connection to her?
Amy said, it's about slope. Mhm.
Okay.
So I think in Amy's head, difference quotient and slope, they are related.
Okay.
Mhm. Alex, it's your turn. So what did you learn? Any Alex? Here. No? Anybody? Mhm. What is the definition of derivative? Isn't it something about changes? So you relate it to your own meaning for slope and the definition of derivative, right? So this is what Alex wrote. So it surprised me because he used a plus as well, right? And because of Alex's meaning for slope, he did something different than Amy. Let's listen to what he said in his post-lesson 3 interview.
Which I realized during the lesson that I wrote wrong.
Today,
Yeah.
you realized it?
Yeah.
What you let me know
That
what you
is-
realized.
Well, before I was saying that it was the limit of delta x approaches 0 as the, I was saying that it's plus, and then that led me to some difficulty during the pre-lesson because you asked me to explain the top part. And then I realized now that once it's a minus, it's just the difference between the values and the points.
How did you
So it
arrive
really
at,
is slow
how did you arrive at this
that I had it wrong.
minus? Yes.
Well, because as I was walking back, I was like, I didn't understand what the top part meant really. I was kind of just like telling you whatever I could come up with.
Is it consistent with what you said? So because of Alex's meaningful slope, it allowed him to realize, right, his error. So I think Alex's meaningful slope worked when he tried to understand Terry's lesson. So Alex realized that he had not represented what he intended, and he wanted to represent changes. And the nature of his realization was he could not represent changes with a plus, right? So Alex is okay because he has pretty good meaning for slope when he understands the definition of derivative. So Alex, you are done, but Amy, you will keep going. So Terry watched Amy's video clip, and let's listen to what Terry said and what Terry felt.
So like different scenarios. So like she's like basically like parent functions to like show like how you would plug in like a function into the derivative function to find what the derivative is. So using the definition of derivative, yeah, right?
So is this consistent with what you intend? Okay.
Is that it's a minus because of the difference, the change in y. She never got that.
Never got.
Okay, I don't know if she knows it now. She maybe does. I don't know, because you've been interviewing her, you probably haven't asked her that same question again. But
Is it your state?
yeah, that's misunderstanding. Writing it plus doesn't make any sense. I mean, like if you know what it's talking about, it doesn't make any sense.
It sounds
So-
like she cannot connect this is a really
It's too abstract.
and rate of change and flow.
Yeah, because she is actually the one, you weren't there, she is the one that said what the slope formula was. Oh, yeah.
Then you
Y,
told slope.
well, y2 minus y1 over x2 minus x1. She isn't making that connection.
Before I came here.
But I'm saying, she's the one that said what the slope formula is, so it's disturbing that she's got a plus there. And I would not have had any idea that she didn't get that.
So this is not consistent with what you intend.
No, not at all.
What do you think? So Terry felt really sad, right? Her sad voice. So I want to emphasize something. So my goal of this study was not to help Terry move or advance her KPU. So I just let her do what she wants. So I'm thinking of a future intervention study by saying something like, I will have Amy do this to address Amy's meaningful slope. But in this study, I didn't do that because it was not my goal. So it seems Terry focused on Amy's action. Amy spoke of the flow formula correctly, right? So Terry thought Amy connected the idea, the slope formula and the derivative, the definition of derivative, right? And Terry didn't consider the possibility that Amy's meaningful slope had nothing to do with changes. So that's why Terry felt really sad, but she said the slope formula correctly. She kept saying that. So Terry only focused on Amy's actions, writing minus or saying y2 minus y1 over x2 minus x1. So Terry put her own meanings into her model of Amy's understanding. Can you see a first order model of Amy? So because Terry was really sad, she talked about her decision to adjust her lesson to help Amy. So Terry said she would emphasize the numerator having a minus by writing this. So her plan lacked anything to convey the top part and the bottom part represent changes, right? But her plan only to help students recall the presence of minus, the top and bottom. So her plans to adjust her lesson didn't indicate any reflection on what she might have not done or she might have done that led Amy to use a plus. Do you agree? So Amy, you should be ready to learn from Terry's adjustment. But I will show you what Terry did in the next lesson. Ready, Amy?
Quick reminder, just a quick reminder. This is what it looks like. No, I'm showing you something that I think I need to remind you. This is what it looks like before you send it. So remember, that isn't that actually just a version of this? Isn't it? Isn't it? Yes? And if you kind of lost that in the shuffle, it's possible for you to have lost that in the shuffle. What we did is what? Back to the slash. Yes? To a limit in front. Made my h approach 0. It is no longer the slope between 2 points, but it's using this concept. The points are what? It's close to each other. I mean, h is approaching 0. So that formula, that might help you remember how to use the formula, because you actually can write it down. H is that little tiny change in x. This is new and this is calculus. Okay? When you do other reflex essay or reflex essay, you're doing pre-calculus and elements. You're doing an average rate of change.
Amy, what did you learn? Did it help you better? No. So can you imagine what Amy said after experiencing this lesson 6, Terry's adjustment? Can you anticipate what Amy would say?
The part she raised with her hand first, that would be my convey, would be my say. I wonder if she's saying, oh, that's the one I knew, and it's pre-calculus.
Uh-huh.
I'm doing maybe.
I like my Amy here. So
I wonder like if she can connect the function notation to like what she said about y2 minus y1 or
Mhm.
x2 minus x1.
yeah, I agree. I think Amy's problem might be something related to function notation or before the definition of derivative, right? But the main reason why Terry had the inconsistency between Terry's intention and Amy's understanding is Terry never thought about Amy's meaningful slope that didn't refer to changes. Do you agree? So her lesson adjustment just try to help students. There is a minus, not plus. Everyone, remember this. Never identified the difference between students' ability, like to use a formula or to speak the formula correctly, and see its meaning for the formula, right? So sadly, Amy didn't do well in post-lesson 6 interview. Let's watch Amy's post-lesson 6 interview.
What is a prime? Affirms the derivative. Okay, how to get the derivative? That is. So then you take the first formula that you are given, which is like a quadratic formula, and then you have to plug that into like the derivative formula, which is I know. Again, you don't have to write down the exact correct formula. Okay, so again, I'm looking at prime. Yeah, this is at prime, right? So what does this mean?
This is like the change in your Y. So I think this is the change in X. So that's how they like connect.
How can you connect?
So like, I mean, it's kind of like rise over run stuff.
Oh, right. Really?
Yeah, because like X is simply Y.
Oh.
So it's like Y plus Y, and then on the bottom it would be like, so like 8.
What do you think? So after conducting this interview, I realized how hard it was to change someone's meaning, right? It's pretty hard. So Amy, it seems like Amy pulled up all things she could remember that she associated with Terry's lesson and put them all together to satisfy herself. But I feel sad, but at the same time, she was so cute, right? Y plus Y, and she kept talking about change, right? That's what she learned. But Amy never used a minus at the end. So the reason is I thought Terry never talked about something like how the final exceeds the initial, like the change. Terry never focused on the change when she taught the definition of derivative. So Amy didn't think it's something about change because she said Y plus Y, and the bottom is going to be H plus H, and she's good. So this is Amy's post-lesson 6 interview, and then Terry watched this lesson as well, this interview as well. So can you imagine how Terry felt? So I'm gonna show you. So Terry watched Amy's lesson, post-lesson 6 interview.
And then you have to plug that into like the derivative formula, which is a lot. So, hold on. I know. Look at it, you even got to write that.
It's a really good point.
She's still in that plus, but please, she did both of them correctly.
Yeah, and I asked her right now the meaning of this top part.
Yeah, this is right? So what does this mean? This is like a change.
Which is correct.
So how
I don't know why she keeps writing plus in there. She does understand. Yeah, I think she does. Anyway, she understands it's check, but now you know what she's done is what I call a bad habit. She's written it enough times wrong. Enough times wrong that it's hard for her to undo that. But I think by Saturday I think it's better.
What do you think?
But she said that she was getting it correct on the quiz.
So Terry kept focusing on Amy's actions, right? Speaking of slow formula or getting the correct answer on the quiz. So I really like Terry because she was a really good teacher. So I think she has the ability to convey what she intends. So I think Terry's main problem was her lack of student image, her image of student thinking. So other than that, she was perfect. The speed of her lesson and her personality, she really cared about students. Can you see? So she felt really sad when she recognized she failed to convey what she intended. So Terry said Amy didn't understand because she did solve problem correctly. So she wanted to believe Amy didn't understand. And Terry focused on neither of the source of Amy's difficulty, which is about her meaningful slope, nor what Amy thought about the difference quotient or the idea of change. So rather, Terry paid attention to Amy's actions. So at the end, Terry called it bad habit. So Terry thought students' difficulty, when she found any inconsistency or student errors, she thought that is a matter of student procedure habit, right? And because she thought Amy said the slope formula correctly, and she would understand the slope. It showed Amy put her own meaning into her model of Amy. Do you agree? The A first order model. So Terry just assumed Amy's meaning matched her own. So when Terry detected miscommunication between her and her students, Terry focused on what Amy and Alex didn't understand instead of what they understand. And Terry's decision to adjust her lessons didn't address the source of students' difficulties. So her lesson adjustment didn't help Amy. Do you agree? Yeah. So Terry,
Oh, I just had a question. Do you feel like Amy didn't have like a quantitative meaning for subtraction, like understanding subtraction provided the difference?
I suspect not, but I didn't probe Amy's meaning for the quantitative using.
It just feels like if someone was in calculus, they
Uh-huh.
would have an image of subtraction meaning a difference. Like that seems like one of the easier things for, advanced mathematical students to know. So that's why I'm confused about why Amy would say change and then not.
Y plus Y.
subtraction. That doesn't seem hard to me based on like my model in calculus.
If you think that change or if slope is up and over, like if she says change, but she doesn't think of changes and actually she's not like thinking of a change, up and over
Could be the plus.
could be the plus,
Oh.
plus Y plus X, like changing that.
She are adding something going up and adding something going over. Oh,
There's other things I was thinking. So I genuinely almost feel like so Amy was the person to bring up Y2 minus Y1. So I feel like there's two things going on. I feel like she does both rise over run. I do think if she had 2 points, she'd be able to do slope. What that made me think of is a lot of students first learn slope around the same time they learn midpoint formula.
oh,
And it's like she's default. That's just what it made me kind of think of. Because like that persistent use of the class. And the other thing is when you show the first clip of the teaching, I wasn't sure what was going on yet, but when the second clip of the teaching, it almost became clear to me that this teacher may not have done seek and slope prior. It seems like she may not have touched it, where she could have connected with the students from their middle school or higher grade understanding of slope, and it's still pretty much the same.
got it.
And graphically, because I also didn't see the graphical representation, or maybe she could have brought in Amy and then carried her along into the tangent idea. So tangent line.
I like the midpoint idea. Because
Yeah.
when you have the H on the bottom,
With single.
it looks like one thing, just like the two. Because I do remember midpoint slope formulas getting like all mixed up, and that would explain why she kept putting the plus, because it's with the one single thing. That makes sense. to me.
Yeah, I like
I
that
don't feel like
hypothesis.
I've seen a lot of people put plus in this question. That was perplexing to me about why.
Interesting. I think you can research on it. I will research on it because it's a pretty good hypothesis. And let me know if you find something good. Yeah. So I think Amy was happy with a plus because of her own meaning for slope or before slope, right? Or subtraction or addition. And Terry's KPU phases, I think obviously Terry moved because at first Terry taught the idea in ways those are clear to her. Nothing about student thinking. And then after watching student's video clip, she moved to phase 2. But Terry didn't see any significance to Amy's meaning for slope, like motion going up and over. And that was the cause of her Amy's difficulty. But Terry never thought about the main reason. So Terry's adjustment was to emphasize this is minus, because Terry assumed student's meaning matched her own. So I think Terry assumed if her students paid attention to Terry's lesson and will observe everything she does, and her students must inevitably build the same meaning as she had. I think that's what Terry thought. So I think Terry, question?
Could you go back to thinking of 2, do you think it would be better to say that should be getting oriented to student activity?
Instead of thinking, yeah.
Like, would that be another way to?
The reason, I think this is Thompson 2008 KPU phases paper. So I think the reason why he added student thinking, this is the first phase
Yeah.
where teachers think about student thinking. But in this case, Terry never thought about student thinking. Is it what you meant?
Yeah, because your data is beautiful, right?
Yeah,
You made a point with your data that
Uh-huh.
she was oriented towards student activity. And so it seems like within that phase is like student thinking and student
Uh-huh.
activity are blurred to the teacher,
Yeah.
right? They're taken as one and the same.
But do you think Terry started to think about student thinking at the end? Or never thought about student thinking?
I struggle,
Uh-huh.
like from her perspective, yes. Like,
Yeah. Mhm.
And I also struggle even making a claim as a researcher, like, yes, I would prefer to claim she was focused more on student
Mhm.
activity. But I think of this in terms of like cognitive development, that
Yeah.
is probably the first phase of
Mhm.
thinking about student thinking,
I agree.
is thinking about student activity
Uh-huh.
and getting operational ways to think about their activity.
Yeah.
And then like through sequences of reflective abstraction,
Mhm,
and
mhm,
taking
mhm.
at the levels that are actually thinking.
Yeah.
Cognitive action.
I had that question in my mind as well. So I realized Terry saw students' difficulties or student struggle as a matter of procedure habit. So that's it. So in my mind, she never thought about student thinking, like student aim is meaningful slope, never. But she kind of moved her KPU phases. I think watching her student video clip helped her, but it was really hard to help teachers move KPU phases.
Yeah.
Yeah, it's kind of habit as well, right?
Yeah.
But thank you for the comments. I will think about it. So her KPU phases influenced the way she expressed her meaning during the classroom, her lesson, and the way she interpreted students' understanding, like Amy and Alex expressed. So, see, I thought Terry never thought about student thinking, had not been an issue in Terry's mind. And then Terry always put her own meaning into her model of student thinking. And when she decided to adopt her lesson, she planned to change her lesson in ways it was clear to her, not to her students. And that's why she put more algebraic steps, and she believed it will help her students. Because in her mind, saying the flow formula correctly and solving the quiz correctly, they are important.
So would you say it's almost like Terry thought that their conceptual understanding might be right, it's just like the procedural, something
Yes,
is wrong?
yes. Do you agree?
Seems like it.
Yes.
She's like, oh, I think they understand what I
Uh-huh,
mean,
uh-huh,
they're just
uh-huh.
right.
Uh-huh.
No, but I
Disconnected.
I just find it interesting because like, even like in the beginning, right, she kept saying like, oh, she knows that she gave the formula the slope. So she just right now struggling with derivative, she just keeps trying as a plus, it's a habit. So I'm almost wondering if she just like projects her own conceptual understanding and then just assumes like, oh, if I just show them enough algebra,
Mm-hmm. Minus.
they're gonna pick it up.
Uh-huh. And she believed they are gonna pick it up at the end by Saturday, right? So does this activity help you as a teacher, as math educators, everyone? I think my research is important because if we think our students' learning is really important, if we want to help students develop their thinking coherently, I think we may have to pay attention to student thinking instead of student activity. And because they are experiencing our instruction. And we are doing a really important job for our students. And I think I'm revealing the nature of the problem, why teachers failed to convey what they intended. So we need to think about as a teacher, as mathematics educators, productive meaning for student learning, like what's gonna be productive meaning for slope, so that students can develop pretty good meaning for the definition of derivative. And or later on, they will use the slope idea. And we have to have clear intention on how to convey productive meaning to students. And we have to keep in mind different ways of interpretation of what we say. And we have to think about the possibilities to guide our instructional action. So study 2, we do have a few more minutes. I want to talk about citizens' interpretations of COVID-19 quantitative data. So the concept for study 1 was the rate of change or slope. So I'm going to introduce an item related to rate of change. So anyway, so Amy and Alex will interpret this data, quantitative data, right? Many numbers, and we do have the percents. So because we are supposed to make our own decision, getting the vaccine or not, or wearing a mask or not, right? So Amy and Alex will try to understand COVID-19 quantitative data. So think about it, how Amy interprets this data, how Alex interprets this data. So this is our COVID pager team's research question. So today I will talk about how citizens' meaningful rate of change help them make sense of the severity of COVID-19. So this is study design. I'm going to skip this. We interviewed 32 citizens in the United States and South Korea last year. And this is the item. I'm going to give you 1 minute to read this item before watching interviews. This item was based on a tweet by the former President Trump on March 9th. So what do you think? Flu is worse or COVID is worse? How many of you thought flu is worse? How many of you thought COVID-19 is worse? This is our result. So some people said flu is worse. Some people said COVID-19 is worse because of some reason. This is our result. And for the sake of time, I'm gonna play the video clip from Bomsu, who is a South Korean citizen.
보통 이제 한국에서 기사를 볼 때는 예를 들면 한국 5천만 명이 몇 명이래서 비율을 보통 따지잖아요. 이렇게 보면 6만 2천 명이라고 하면 되게 커 보이는데 사실은 이제 되게 낮은 퍼센트로 계산이 돼버리니까 그래서 여기에 뭐 일상생활을 진단하지 않는다 맞죠. 근데 네. 다만 지금 보면 뭔가 기준이 일관되지 않았다는 좀 생각을 살짝 들어요. 보면은 이 독감은 10월부터 3월까지면은 11월, 12월, 1월, 2월, 3월 5개월이잖아요. 5개월에 6만 2천 명이면 나누면은 한 3천 명 정도 되거든요, 한 달에. 근데 4월 2일에는 하루에 1만 명인 거잖아요. 이렇게 보면 훨씬 더 코로나가 위험한 거 아닌가? 라는 생각이 좀 들어요.
How do you feel? Do you think Bomsu is using his own meaning for rate of change? So he
Can you
used.
go back to the English version of the item?
Sure.
Like, sorry.
This one?
Yeah.
So Bomsu thought about the changes, right? The number of deaths and the period, the time elapsed. So he created the changes and compared, and he concluded COVID-19 is worse. Can you see? And I will play one United Citizens video clip as well, so that you can compare the two citizens videos. Ready for minutes? I think you can see James here.
The flu is worse than the coronavirus. We don't shut things down for the flu, so we shouldn't for the coronavirus. Yeah, I agree with that.
Do you agree with that?
Yes.
So
I guess it's the same argument, like sugary foods and smoking kill more people than the coronavirus, but we don't outlaw them or we don't shut down stores and sell them.
What about the specific, yeah, so what about the numbers specifically lead you to agree with the argument?
The higher numbers of flu.
Yeah. As compared to the higher number, or as compared to the lower numbers of coronavirus.
Of coronavirus, yeah.
What do you think? So I got two thoughts when I analyzed this interview data. Number one, rate of change, the meaning for rate of change or slope is really important because in our real life, right? It's useful to make our own decision, wise decision, right? During the COVID-19 situation. Number two, I think personally, Bomsu, Alex is likely to be Bomsu, right? Because of his meaning for slope or rate of change, and Amy is likely to be Kenneth. Yeah, so I think it's gonna be my hope if you feel the meaning and the meanings for rate of change or slope, they are really important to teach. I think I succeeded in conveying something today. So this is all I have for today, and thank you everyone. Let me know if you have any questions. Zero, yep.
So did you mention, so that, are you seeing this as the next step of like trying to do multi-intervention?
Intervention.
Yeah, like how do you see, what do you see as the next step for you? For this?
As I told you, I didn't do anything for Terry, but for the next intervention study, I'm thinking about, I actively will work with Terry. So let's do this to help Amy. I think I will tell Terry if this is an intervention study. Terry, I think the main reason why Amy having difficulty is going to be her own meaning for slope. Let's focus on the change. Let's talk about how the final exceeds the initial, top and bottom. The numerator and the denominator, they each represent the change. Let's use the points or numbers to see why we have to use the subtraction, like that. Did I answer you?
The first time I saw the represented the definition for birthday, I believe I saw changes for the page. And the student, the male student, who expressed it as delta X. And then I think the second time she used delta X. I'm just trying to understand, did she switch between those two when her teaching?
Yes.
Or did that student use it?
Yes. She mixed two ways, delta Y and delta X and H. Nina?
I saw a lot of teachers who only focus on students' actions in their school, very big about the Amy's results. Is there any other comments of using these meanings of the importance of teachers' meaning to convey students for teachers who only think about? I mean, like the teacher. I think it's about teacher tendency to just admit their teaching and learnings are okay because of their instructional pressures. So it's related.
Any constraint when they teach or time or something?
Probably there's some constraint, but I think that some of those teachers have a lot of beliefs on they have to do something for their students. They have to make some results after their lesson.
Like test results.
In their case, is there any ways to help them to move to the importance of teachers' meanings to students? Like,
so I wanted to emphasize something. So Terry's meaning for slope or rate of change were good. So there are three things: teacher's meaning in Terry's head and the way she expressed the meanings. But I think her main reason why she failed to convey her meaning was not her meaning, her KPU. Because she kept projecting her own meaning into her model of student thinking. So she kept thinking, oh, Amy said the flow formula correctly. She understood it. Yeah, so it's not about Terry's meanings, it's about her KPU. So I know it's pretty difficult to cover all product meanings in the classroom, but at least after watching Terry's students' misunderstanding in the video clip, Terry could do something like focusing on changes. It may take a lot, but I think it's worth it. Did I answer you? Any other questions? No. Thank you, everyone.
Before everyone leaves, I just want to invite everyone to